In this video on map scale, we're going to look at 3 different types of scales and how we use them in the proper way. So for this video, you're going to need, again, your textbook. You will also need your atlas. You will need a calculator, a printed copy of the PowerPoint presentation that goes with this video, a printed copy of the study guide for Chapter 2, and a printed copy of the conversion factors handout, although I will be giving you the conversion factors during the video as well. So again, feel free to stop the video at any time when you need to work out problems. And then any figures that are referenced by numbers in this video are from Chapter 2 in your textbook. So when we talk about map scales, there are actually 3 different types of scales that we use. We use what's called a graphic scale, we use a fractional scale, and we use a verbal scale. And they are very different in the way that they work. The graphic scale is a graph, so it's represented by a bar graph, and you have an example on this slide. The fractional scale is given as a fraction. It's always given with a number of 1 on the numerator, and then another number of the on the denominator. And the fraction is represented by a colon, with the number on top of the fraction is always 1. And then you have another number, usually much greater than 1, on the bottom. And then you have a verbal scale. An example of a verbal scale would be 1 inch to a mile, 1 centimeter to a kilometer, and so on. So first we're going to talk about the graphic scale. So the graphic scale is represented by a bar graph. The advantages of a graphic scale, there are actually 2 big advantages. It's very visual, so you see directly what distances are like. And also, if you decide to shrink a map on the copier to enlarge it, the graphic scale is still accurate. And by the way, I have another video on how to use a graphic scale that I've made a few years ago, and that's also linked on the Chapter 2 files page. Please make sure to pause that to learn how to use a graphic scale. I'm going to go over some of this here, but the other video is in some ways more complete. Okay, so let's see how we use a graphic scale using the map pages 56 and 57 in your atlas. So this is a map of southern Africa, and notice the graphic scale here at the top left, and notice that you have 2 graphic scales, 1 in kilometers and 1 in miles. So first we're going to use inches into miles. So the first question is 1 inch on the map represents about how many miles on Earth? So what we do is we just measure directly with a ruler in inches. I prefer transparent rulers. They're easier and more accurate to read. And we start from the 0 here on this graphic scale. So we're line 0 and 0 on the scale and on the ruler. And then we read here 1 inch on the ruler, meaning 1 inch on the map, would be how many miles on the ground. So we are halfway through this white field here. So this would be, we have 100 and 150 here, so this would be 125 miles. So then for 3 inches on the map, we could measure it, but we could also just multiply by 3, and we get 375 miles. Now, in order to figure out the distance between Cape Town, which is down here in South Africa, and Port Elizabeth, which is right here, what we do is we don't actually use a ruler for this. We use something that does not have any graduations. So a blank piece of paper is just great. So we take the piece of paper and we align it carefully to the center of both towns. Here I'm having a hard time because my atlas is not flat. And we put tick marks to those 2 locations. Okay? So now we have a distance on the map between Cape Town and Port Elizabeth. So then we use the graphic scale. We start at 0. Okay? Well, the graphic scale is not long enough, so we make another tick mark here, and we know that this is 200 miles. So then we go back to 0, and this is another 200 miles. So that's a total of 400. And then we have this little bit left. I notice on the left on the scale, we have another graphic scale that goes from 0 to 50, but is more accurate. So we're going to measure the remaining on this scale. And we get 10, 20, it looks like 25. So that would be a total of approximately 425 miles. On my presentation, I had 430 miles. Again, we're doing this if we want it to be really accurate. Our tick marks would need to be very, very accurate. So now we're going to use the same map again, the map of South Africa, or Southern Africa rather, pages 56 and 57 in your atlas. And we're going to use the graphic scale, but now this time we're going to work in centimeters and kilometers. So the first question that we ask ourselves is 1 centimeter on the map represents how many kilometers on the ground, and that's using the graphic scale. So again, we take a ruler, but now we need a ruler that also has centimeters, and we align the 0 on the ruler to the 0 on the kilometer scale, on the kilometer graphic scale. And then we read directly what 1 centimeter is on the graphic scale. So we see we are within this green field between 50 and 100 kilometers, but closer to the 100 kilometers. So this could be approximately 80 kilometers, maybe 75 or 80 kilometers. Then the next question we had to answer was 3 centimeters on the map represent about how many kilometers on the ground. We would just multiply 80 by 3. And then now we are trying to figure out the distance between the same 2 towns, Cape Town and Port Elizabeth, but this time in kilometers. Again, we don't use the ruler for this. We just use a blank piece of paper. And, well, I'm going to do new tick marks, actually. So we put a tick mark through Cape Town, and then through Port Elizabeth, we transfer the distance between those 2 cities on this piece of paper. Now, for you, it should be easier. Your atlas is going to be horizontal, so you should be able to align it a little better than I'm able to here. And this time, because we want to know in kilometers, we're using the graphic scale in kilometers. So from here to here, we have 300 kilometers. And then again, we go back to the 0. We have another 300 kilometers. And then it looks like this is more than 50, so we do 50 here. And then we do the last little bit again on the left side. So we have 10, 20. So we have 670 kilometers, approximately 670 kilometers. On my presentation, I had 685. Again, this is, when we do the graphic scale, it's not going to be an exact number, so the numbers may vary a little bit. So now I would like you to go to the map pages 76 and 77 in your atlas and try to do the same thing. So using the graphic scale, measure 1 inch on the graphic scale on the map, and then answer 1 inch on the map is approximately how many miles on the ground. Then figure out 3 inches on the map is approximately how many miles on the ground. And then figure out the distance between Reno and Salt Lake City using the graphic scale. So here are the answers for question 1A in the study guide. For the distance, 1 inch on the map is approximately 110 miles on the ground. 3 inches, approximately 330 miles on the ground. And distance between Reno and Salt Lake City in a straight line, obviously, is approximately 430 miles. So with this in mind, I'd like you to go back to the map of the United States, pages 76 and 77, and using the graphic scale now find the same kind of information, but now in kilometers. So 1 centimeter on the map using the graphic scale is approximately how many kilometers on the ground. 3 centimeters on the map is approximately how many kilometers on the ground. And the distance between Reno and Salt Lake City is approximately how many kilometers on the ground. So again, you might want to stop the video now, figure those out on your own, and then when you're ready, come back and check the answers. So here are the answers for this question in kilometers on the map, pages 76 and 77. So next, we're going to learn how to use the fractional scale. So the fractional scale is a fraction. It's a ratio. It's really what it is. So it gives the ratio of the distance on the ground compared to the distance on the map. And I call the distance on the ground, I call it the distance on the Earth. So it's expressed as a fraction. The number on the top of the fraction, or on the left side of the colon symbol, which is the numerator, that number is always 1 on a fractional scale, and it always represents the distance on the map. The number on the right of the column is always greater than 1, and it always represents the equivalent distance on Earth. A fractional scale has no unit. It can be used with any unit. So you can use it with inches, you can use it with centimeters, you could use it with finger length, toe length, whatever. But what you have to keep in mind, the fractional scale itself has no unit, but when you use it, you have to be careful that you use the same unit. So, for example, if I have a scale, a fractional scale of 1 to 24,000, and that's how we read that fractional scale, 1, the colon is read as 2 TO, and then 24,000. So a scale of 1 to 24,000 means that any 1 unit on the map is equivalent to 24,000 of the same units on the Earth. So I could say 1 inch on the map is equivalent to 24,000 inches on the Earth. I could say 1 centimeter on the map is equivalent to 24,000 centimeters on the Earth, and so on. Same thing with 1 to 48,000. 1 unit on the map, in this case, would be equivalent to 48,000 units on the Earth. So, first example, let's consider a fractional scale of 1 to 48,000. So 1 inch on the map, on such a map with a fractional scale of 1 to 48,000, is going to be equal to 48,000 inches. That's how the scale works. But when we use a fractional scale, if you were to tell somebody, oh, 1 inch on the map is 48,000 inches on the Earth, it's like, okay, 48,000 inches on the Earth, what's this? So it's useful to convert those inches on the Earth to either feet or miles. So to convert from inches to feet, we have to divide by 12 because we have 12 inches per feet. And we get to 4,000 feet. And if we want to convert from inches to miles, then we have to divide by, I like to go directly from inches to miles, and the conversion factor is 63,360. You have that on your conversion sheet, so you don't have to memorize those factors. And so 48,000 divided by 63,360, because there's so many inches per mile, gives you 0.76 miles. And I like to go directly from inches per miles, not from feet per miles, because sometimes when you go from inches per feet, you don't get a round number. And so you get an approximation, and if you start from this number again, then you just get more of an approximation. So I just like to use the direct conversion from inches per miles. Okay, so then we are interested maybe in knowing not just what 1 inch on the map is, but maybe more than 1 inch. So in this case, I have chosen 5 inches on the map. So how would we calculate the distance on Earth that is represented by 5 inches on the map? So we have to take 5, multiplied by 48,000, because every inch is 48,000 inches on the ground. So we get that many inches on Earth, which is 240,000 inches. And again, we want to convert that into feet and into miles. So to convert into feet, we again take the 240,000 inches divided by 12 inches per foot, and we get 20,000 feet. And then to convert to miles, we take 240,000 inches divided by 63,360 inches per mile, and we get 3.79 miles. We could also have worked from the numbers on the preceding slide and just multiplied by 5 from those numbers. So now again, I have an example for you to do on your own. So this is question 2A in your study guide. If you consider a fractional scale of 1 to 24,000, what is 1 inch on the map in inches, and then 1 inch on the map in feet on Earth, 1 inch on the map in miles on Earth, and 3 inches on the map in miles on Earth. So this would be a good time for you to stop the video, work those problems out. And then here are the answers to question 2A in your study guide. So we've done exercises with fractional scale, just thinking of a fractional scale in our mind, not referring to any specific map. So next, we're going to refer to a map in your atlas. We're going to go to map pages 56 and 57 in your atlas, and we're going to figure out what the fractional scale is, and we're going to answer the same questions as we did before, but in reference to this specific map. So you find the fractional scale for the map in pages 56, 57. They are typically, typically they are at one of the corners of the map. So you need to find that fractional scale, and for that particular map, it's 1 to 8 million. So when you try to figure out what 1 inch on the map represents on the Earth, it works the same as before. Now you have 1 inch on the map is 8 million inches on the ground. And then that distance on the ground or on Earth, you want to convert to feet and to miles. So to convert to feet, you divide by 12. And then to convert to miles, you start from the 8 million inches and you divide by 63,360. And then the last question here is 3 inches on the map represents how many miles on Earth? You could take the number above, 126.3, and multiply by 3. Or you can start over. Here I have started over. I take 3 inches, times it by the scale of 8 million, and then divide by the conversion factor for inches to miles. In both cases, you should get the same answer or very close to the same. Now, what we're going to do next is we're going to now calculate the distance between Cape Town and Port Elizabeth using the fractional scale. So for this, I'll need to show you on the map directly how to do this. Okay, so back to the map pages 56 and 57 in your atlas. Again, we're going to figure out the distance between Cape Town and Port Elizabeth. But now we're going to calculate the distance using the fractional scale. So remember earlier, we did the distance using the graphic scale. And we just use a piece of paper to use the graphic scale. Now what we're going to do is we're going to accurately measure the distance in inches between Cape Town and Port Elizabeth. So we use our ruler directly on the map to measure that distance. And when you do this, you end up with a distance of 3 inches and 3/8 of an inch. So when you have that distance of 3 inches and 3/8 of an inch, you first need to convert that number to a decimal number because we have a fraction now, 3 and 3/8. So 3 and 3/8 is 3.375 inches. And then we use the fractional scale like we did earlier on. So we take that distance of 3.375 inches. We multiply by the fractional scale of the map, which is written here. It's 1 to 8 million, so we multiply by 8 million. And then to convert that into miles, we divide by 63,360 because there are so many inches in a mile. And we end up with a distance of 426.1 miles. So next, I have question 2b in the study guide for you to work out. And you should work this question out with a map that is pages 76 and 77. So now you're going to be using the fractional scale to answer those questions. So 1 inch on the map is how many inches on Earth. 1 inch on the map is how many feet on Earth. 1 inch on the map is how many miles on Earth. So now would be a good time for you to pause the video and answer this question. And then when you're ready to go on, I'm going to post the answers on the next slide. So here are the answers for question 2b in the study guide. Okay, the last thing we're going to do about fractional scale is we're going to do just what we did on a map in your atlas, but now we're going to use centimeters and kilometers. So first we're going to consider a hypothetical map with a fractional scale of 1 to 50,000. And we're going to ask ourselves, 1 centimeter on the map represents how many centimeters on the Earth? So we do the same as we did for inches, but now we're doing it with centimeters. So 1 centimeter on the map is just 50,000 centimeters on the Earth. So then we're going to convert these centimeters on the Earth into meters and kilometers. So to convert from centimeters to meters, you need to divide by 100. Again, refer to your handout with conversion factors. So we take 50,000 centimeters, divide by 100 centimeters per meter, we end up with 500 meters on Earth. And then we want to know how many kilometers this represents on Earth. So we take 50,000 centimeters, and now we divide by 100,000, because we have 100,000 centimeters per kilometer, and we end up with half a kilometer, or 0.5 kilometers. Again, you have all of these conversion factors on your conversion factors sheet, and remember that you can use that conversion factors sheet for your exam. So next, we're going to ask ourselves what another distance on the map is represented by on the Earth. So here again, I've chosen 5. I could have chosen another number. So 5 centimeters on the map is represented by 5 times 50,000 centimeters on the Earth. 5 centimeters on the map, we take that 250,000 centimeter number, we divide by 100 centimeters per meter, we get 2,500 meters. And then we want to know the distance in kilometers. So again, we take the 250,000 centimeters and divide by 100,000, and we get 2.5 kilometers. I find it quite a lot easier to do centimeters to kilometers than inches per miles, but we do want to do inches per miles because that's mostly what we use here. Okay, so again, I have an example or a problem here for you to work out. So this is question 2C in your study guide. So again, this would be a good time for you to definitely pause this video, work those problems out, and then check in the answers when you are ready. So here are the answers for question 2C in your study guide. Okay, finally the verbal scale. So the verbal scale, it says verbal, so what it means is it's something that you use verbally. It's the scale of a map as stated in words. It's often an approximation. So examples of verbal scale would be 1 inch to a mile, 1 inch to 125 miles, 1 centimeter to 80 kilometers, these kinds of things. So keep in mind they're often an approximation, but it's just to give you an idea of really, a certain distance on the map. What is the actual distance on Earth? So, for example, if you go to the map, pages 56 and 57 in your atlas, what would be an approximate or an appropriate verbal scale for this map? An appropriate verbal scale would be 1 inch to 125 miles or 1 centimeter to 80 kilometers. And you could actually use the graphic scale to measure on the graphic scale the approximation here. So you would not give a verbal scale as like 1 inch to 113 miles. No. Again, a verbal scale is going to be approximate. So it would be 1 inch to 100 miles or maybe 1 inch to 125 or 1 inch to 150 miles, depending on the actual scale of the map. But it's an approximation to give a quick idea of the scale of the map. One concept that is often hard to understand is the concept of large and small scale. And that's because on a map with an actual scale, when we say large and small scale, we use it the opposite way of what we use large and small scale for in everyday life. For example, if I say a large scale phenomenon, I'm thinking a phenomenon that's really affecting a wide area, whereas a large scale map shows a small area. So why is a map of a small area called a large scale and a map of a large area called a small scale? That's because it refers to the fractional scale. So remember that the fractional scale is a ratio. For example, remember we had a fractional scale of 1 to 24,000, or a fractional scale, let's say, of 1 to 100,000. So think of it as a ratio. That means that ratio 1 to 24,000, think of it as 1 divided by 24,000. A scale of 1 to 100,000, 1 divided by 100,000. Okay. So let's look at figure 3 in your textbook to try to figure that out. So in figure 3 in your textbook, again in chapter 2, you have at the top a small scale map, and as you get towards the bottom, you have larger and larger scales. So look at the fraction. Look at the fractional scale. The top map has a scale of 1 to 100 million. The bottom map has a scale of 1 to 250,000. So as the bottom number of the fraction gets bigger, the scale gets smaller, because again, it's like dividing 1 by that number. You're going to get a smaller and a smaller number. So when you divide 1 by 250,000, like the bottom map, you get a larger number than if you divide 1 by 100 million. So that's how you have to remember large and small scale. So the bigger the number on the denominator of the fraction, the smaller the scale. So as a result, a large scale map shows a small area in a lot of details, whereas a small scale map, like the top map, shows a much bigger area in much less details. And again, it's really the opposite of how we use large scale and small scale in everyday life. But that's because it is based on the fraction. Okay, so with all this in mind, now I have just a very few, very basic questions, multiple choice questions about scale. So you have a representation of a scale here. So what type of scale is this? So this is obviously a graphic scale. That's the one that's graphic or visual. 1 inch to 10 miles would be an example of a verbal scale. So A is the correct answer. 1 to 50,000 is an example of course, a fractional scale. And then here you have 3 maps. You have a map of the US, you have a map of Nevada, you have a map of the whole world. Now, I'm not giving you the fractional scales of these maps. So you're going to have to base your answer exclusively on the amount of area of the Earth that is represented. The map are approximately the same size. You know, they are not hugely different in size, but they represent a different amount of area. So based off that, which of these maps has the smaller scale? Is it A, a map of the US, B, a map of Nevada, or C, a map of the whole world? Well, it would be C, the map of the whole world is a smaller scale because it's representing such a bigger area on approximately the same piece of paper. And then same question, but now which of the maps has the larger scale? Well, it would be the map of Nevada because it represents a smaller area, so it's going to represent it also with more details. So B would be the answer. Okay, so in this video, we looked at the different types of scales, graphic scale, fractional scale, verbal scale, how to use them, and we also talked about the concept of large and small scale.